Hello and welcome to the maiden edition of Agribiotech, a program that highlights the importance of biotechnology to agriculture and food security in Nigeria. We start off this program with basic definitions so that you can be abreast with what biotechnology entails and how beneficial it can be to various arms of agriculture. I am Lara Afolayan. The average Nigerian loves food, but there is a lot of struggle making this food available. This is because Nigeria spends more than 7 trillion naira importing tons of food annually to meet the feeding demands of its huge population of over 180 million people. One of the improved food production options available to the country is genetic modification. On this edition of the program, we focus on biotechnology and its impact on food production. How exactly does this technology work? The thrust shall be on what the technology entails and how it could impact the Nigerian agricultural sector positively. Genetic modification, also known as genetic engineering, is a technologically advanced way to put in place desirable traits in crops. Though selective breeding has been in existence for thousands of years, scientists describe modern biotechnology as more effective and efficient because it allows seed developers directly modify a crop's genome.
Genetic modification involves either the removal or addition of maybe a foreign gene into the genome of either a plant or an animal in order to improve the process. To improve the traits of the plant or animal that we want to engineer. It involves getting a source of the gene that we are interested in and also creating the construct of for the transformation. And then of course we do the transformation. Before we go on, once the transformation is done and the selection is made for the one with the correct trait, then we are ready to move to the laboratory for further work.
Plants genetically engineered have been selectively bred and enhanced with genes to withstand the common problems faced by farmers. Examples include strains of wheat that are more drought resistant, maize that can survive pesticides, and cassava biofortified with additional nutrients. These modified crops also have higher yields with huge potentials of enhancing food security.
Genetic engineering is being used for various activities. It could be to improve, maybe the tolerance to drought. At this time with climate change, this is quite necessary. Or it could be, for example, for us to put a gene to improve the nutrition. So we have to look for the source of the gene and then we put it.
Genetic modification could shield crops from threats to bountiful yields, such as diseases, droughts, pests, and the negative impact of herbicide use in weed control. This in turn helps in the efficiency of food production. Genetic engineering allows new plant breeding traits to be developed faster. It is more precise than conventional hybridization and likely to produce unexpected results.
Food technology gap in Nigeria is so large. The food security is challenged by very low quality of seeds, and the technology has potential of producing seeds that have very high output in terms of yield. And the yield expectations from this technology will promote the farmers' income. And particularly in the areas of pests and diseases, there are specific pests and diseases that limit production, and especially with the kind of advances that Nigeria is making in the BT cowpea production using this technology, it is something that will help farmers to get more seeds and get more yield, and then of course expand their income expectation. So the technology has a lot of potential.
Genetic modification could improve the nutritional profile of food and serves as a key element in reducing rates of malnutrition globally. Genetically modified food has been in the food supply chain of countries like the USA, Canada, Brazil, Argentina, and India for about 20 years.
For every nation to grow or develop, we need technology. So it shouldn't be a negative case for the technology in agriculture or food. We just need that technology. The biotechnology as a means for food security, as a means for environmental protection, as a means for healthcare, as a means for industrial development.
In Nigeria, the Open Forum on Agricultural Biotechnology is a platform that allows for interactions among stakeholders on exploring new ways of bringing biotechnology's benefits to agriculture. OFAB, which exists in 7 African countries, is an initiative of Kenyan-based non-governmental organization, the African Agricultural Technology Foundation, ATF. Dr. Rose Gidado is the country coordinator of the Open Forum on Agricultural Biotechnology, OFAB, in Nigeria. What exactly is genetic modification?
Genetic modification is a technique that is being applied to change the gene makeup. That's the gene makeup, the DNA of organisms. It could be plants, animals, or microorganisms, or humans. And that technique was actually discovered by scientists a long time ago, based on the understanding of DNA. DNA was discovered in 1953 by Watts and Christen. And it was discovered that DNA is actually the code of life. There are so many things in our bodies that are being controlled by genes, the way you look, the way your eyes is and what. And so it's actually a very unique structure, and is found within any living organism, be it plants, be it microorganisms, be it animals, even to the insect level. And so when they discovered that, they now use it as an advantage to actually modify either plants or modify human beings. Like in medicine, you could use this genetic modification to change the genetic makeup of sickle cell patients from SS to AS or AA. And of course, once you do that, you are restoring life back to these sickle cell patients. We know how devastating sickle cell is. Most of these children suffer a lot of crisis, and most of the time they're being thrown out of school. Sometimes they stay away from school for 2 weeks. They're being hospitalized. Once it sets in, that is it. And and the best way, of course, to address this sickle cell disease is by the use of this genetic modification technique, that's stem cell transplantation. And then we also have gene therapy, and all these are based on the understanding of the DNA. With gene therapy, you can cure cancer, you can cure diabetes, you can cure a lot of diseases. And all these are to our own advantage, to our own comfort, to increase, our days on earth and so on and so forth. So it's been applied not only in medicine, also in agriculture, also in environment, of course for environmental sustainability, especially in the Niger Delta areas where we have oil spillage. The oil spill areas are not arable, but you can use this genetic modification to modify some microorganisms around that area that can mop up the oil spill area and make the land arable for agriculture.
So how exactly does this process work in agriculture?
In agriculture, you can use this technology to modify crops, to make those crops resist some insects and pests that always cause a lot of losses, to agricultural productivity. These insects and pests are very, very notorious, and the use of chemicals is never enough. Sometimes they grow resistance to these chemicals, and the farmer has to spray a lot, 9 to 10 times sometimes, before he's able to, to have high yields or strong yields. It's a very, big problem to the farmers. And not just that, also for nutritional enhancement, to make some crops highly nutritious. For example, we have sorghum. Sorghum is a carbohydrate-based crop and is mainly eaten in the northern parts of Nigeria. It's used as a weaning food. So, but because it is carbohydrate-based, most of these children that take pap, the akamu that we make, is mostly from sorghum. It's devoid of some of these essential nutrients that is really very, very important for their growth, for the brain development, for high IQ, and so on and so forth. It's devoid of vitamin A, it's devoid of iron. And you know what iron means to the body, because lack of iron causes anemia. When you go to the villages, you will see them with stunted growth. You will see them with big tummy. They end up with kwashiorkor, beriberi. So, but with this genetic modification, you could genetically engineer or genetically modify sorghum to have high levels of vitamin A, iron and zinc, which is very, very important. And with this, at least children would have access to some of these very essential nutrients. Things like soybean. Soybean was developed to be herbicide tolerant, and so on and so forth. We have so many other problems, where this technology is used in agriculture, of course, to combat climate change. We know that climate change is real, is there. We are seeing it, we're experiencing it. The rise in temperature, it's it's really something to have worry about. For every 2 degrees rise in temperature, we have it in research, a research that was conducted in 2014 by Ilo et al. Says that for every 2 degrees rise in temperature, we have seeds of rise of sorghum, of millets, that cannot germinate. This is so alarming. If we don't find solutions to this problem, this climate change problem, it will get to a time that actually many people will be dying. Presently, we lose so many people these days because of hunger. So we need this technology to really combat, to develop crops that will be climate smart, crops that will be resilient to these harsh weather conditions that's coming in. And if you use the technology, you can develop crops that will be will reduce the use of these fertilizer. You know what fertilizer is? You use a lot of it. It also brings in these greenhouse gases, emission and so on and so forth.
You've spoken so well about this technology, but how healthy is it? How healthy?
The technology is very, very healthy because it is highly regulated. It has safe history of use for more than 21 years. I think it's getting to 22 years of history of use in other parts of the world, in the developed nations, in US, in Brazil, in Canada, in India, in Africa, in South Africa. The technology is commercialized, has been commercialized since 1996. And so that history of safe use, of course, has given us that confidence. And then the endorsement of the safety of this technology by the World Health Organization, that's another breakthrough. That is to tell you that the World Health Organization is also part of this. For any food in any country, for any genetically modified food or crop or product in any country to be commercialized, of course, it has to conform to the international standards set up by WHO, by FAO, by OECD, and so on and so forth, all of them. And then there's also endorsement by over 111 Nobel laureates have endorsed this technology. And also over 5,000 scientists have also endorsed this technology. They've come out to say enough is enough.
Even with all these endorsements and the facts that have been established concerning this technology, some people still argue that it's not natural. How will you react to that?
It's very natural because the whole system revolves around the DNA. It revolves around the use of living organisms. And within the living organisms, you're going down to the genetic level. You're picking a gene, even though I know that the gene you're picking could be from an unrelated species of a crop to an unrelated species. So it overcomes that boundary that was there, or that boundary that's there if you are using conventional breeding method or hybridization, because in hybridization you have to work within same species of crops. But with genetic modification you can work outside species, and that gives you that increases the gene pool. So you have no, there's no any borderline. So your gene pool increases because you could pick, if you identify a gene, but that gene you're picking, you're not picking an artificial gene. You're picking it from a living system. So we have the timing and so on and so forth. So it's a double helix structure, and the way it is in one organism is the same thing. It's just what differs is the sequence of arrangement of the gene. That is what gives you your own unique nature. So, and you're picking that gene from a living organism and then taking it to another living organism. It's just that they don't have to be within the same species or what. So that is not artificial. That makes it to be a natural process. It's a biological process that has been established from time immemorial.
Okay, and what does this technology hold for the Nigerian agricultural sector?
It holds a very great promise, because with this technology we can transit from subsistence farming to business farming. You know, for us to really do business agriculture, especially at this time that we are trying to diversify our economy, and agri is first and foremost on Mr. President's agenda, and so we need technologies like this to really move forward, to be able to do business. You know, for you to be able to cultivate a very large expanse of land. If you're doing business, you can't do these small ones, the farmers, the peasant farming. It can't take us anywhere. We have been in it for years. Our farmers have been enslaved. But for them to move out, we need to develop these crops, in such a way that no matter how little your harvest will be very, very strong. Because farming is all about harvestable yield, having very strong yields. If you don't have strong yields, you're gone. But with this technology, there's nothing you can do. I mean, with this technology, you can do everything. There's no ceiling, So you'll be able to develop crops that are climate smart, that are resilient to harsh weather conditions, that are resistant to some of these pests and diseases, and all, that have nitrogen use efficiency. Nitrogen use efficiency means using less fertilizer, and that is environmental sustainability, because more fertilizer causes more harm to the environment, because as it rains, everything goes down to the rivers, the tributary rivers that we have all around our world. And then the effects of some of these chemical spray that our farmers use on their farms and what. And then health benefits is also there, because if you're using less number of sprays, let's take for example, if you were in your conventional breeding using like 10 sprays or 9 sprays, with this technology, your spray goes down to 2 number of sprays, especially in BT cotton and then in BT beans, the beans that is being developed at Zaria. So it's only 2 number of sprays, and the 2 number of sprays you're actually using is for the non-target insects. If I have developed my crop to be resistant to Maruca larva, it's the larva, the caterpillar of an insect. Most of these caterpillars destroy the insects. So, but any insect, if I have developed my crop to resist Maruca, any insects outside the family of Maruca will not be affected. You understand? That's where the environmental sustainability comes in. It won't be affected. It can only affect insects within the same family with Maruca insect. So we have the ecosystem is not really distorted. But if I'm using chemical, all insects, non-targets and the target insects, all of them are affected. You spray all and they all die. And even you yourself, that is using the spray, you're inhaling. The chemical you're inhaling is not healthy for your lungs. And that's why most of these farmers, they don't live long. And then there's labor intensiveness. So it's all part of it. So with this technology, I mean, as in its usefulness, its benefits, its importance cannot be overemphasized. This is just tips of the iceberg. There's so many other things. It's just that time is not on our side. But I can go on and on and on and on.
And thank you very much for joining us on the program.
Thank you, Omolara.
And that was Dr. Rose Gidado. She is the country coordinator of the Open Forum on Agricultural Biotechnology here in Nigeria. And at this point, we'll take a look at more facts about the GM technology. Stay with us.
that genetically modified organisms, GMOs, are safe and do not pose any risk, hazard or danger to human, animal and the environment? Neither do they cause cancer, infertility, sterility, tumor or any adversity. There is safe use of GMO drugs like insulin, vaccine, rapid diagnostic test kits for malaria, HIV, hepatitis and so on. The safety of GMOs is certified by the World Health Organization, WHO, Food and Agricultural Organization, FAO, European Food Safety Authority, EFSA, the National Academies of Science globally, the Royal Society, UK, and over 110 prize Nobel laureates. GMOs are safe, effective, and certified by MBMA in Nigeria.
This message is brought to you by the Nigeria chapter of the Open Forum on Agricultural Biotechnology (OFAB), supported by the National Biotechnology Development Agency (NABDA).
There are quite a number of concerns about the GM technology in Nigeria. One of such concerns is from Adeyemi James, who wants to know what genetically modified organisms are. I have a response to that mail from the Open Forum on Agricultural Biotechnology, and I read: genetically modified organisms can be defined as organisms in which the genetic material, that is, the DNA, has been altered in a way that does not occur naturally. This technology is often called modern biotechnology, gene technology, recombinant DNA technology, or genetic engineering. It allows selected individual genes to be transferred from one organism to another, and this could include non-related species. Such methods are used to create GM plants, which are in turn used to produce GM food crops. GM foods are produced basically to increase food production, improve the nutrient value of food, and improve agricultural practices. That was the Open Forum on Agricultural Biotechnology's response to the mail from John. And with that, we come to the end of Agribiotech for this week. Keep the mails coming on what you need to know about the technology. Our email address is agribiotech1@yahoo.com. You could send us a tweet at agribiotech13 or visit our Facebook page, Agribiotech on TVC, to drop your comments. Let's do this again same time next week. I am Lara Afolayo. It's bye for now.
Brought to you by the Nigeria chapter of the Open Forum on Agricultural Biotechnology (OFAB), supported by the National Biotechnology Development Agency (NABDA).